So, next question. Now, here we are going into the entity of the factors which affect the enzyme activity. So, a researcher studies an enzyme catalyzed reaction and observes that the enzyme activity sharply decreases at a pH of 4.6. However, when the pH is adjusted to 7.4, the enzyme regains its full activity. Which of the following is the most likely reason for this reversible loss of activity at pH 5? Okay, so what is the factor which has affected the enzyme activity? Before that, let's see what do we mean by an enzyme activity. So, we know our famous equation E plus S would give us ES, which dissociates to E plus P. So, what is the intention? The intention is to get a product and to get that product as fast as we can. So, that is representing the rate of reaction. Rate of reaction. When we say rate, we always talk about the velocity. Okay, rate means reaction. If I were to plot a graph like this in the x-axis, so this is the x-axis, this is the y-axis, what comes in the x-axis is the substrate, this comes in the x-axis. What comes in the y-axis is the velocity, the velocity comes in the y-axis. Now, when I increase the substrate, okay, and we see the velocity changes over here. Okay, so this is a common rate of reaction. So, when I add the substrate, we assume that the enzymes are present and we see that the maximum velocity at what point it is reached. So, this is just a basic of what is an enzyme activity. Then we see what is another important part of the enzyme activity is we refer to the Km. So, Km and Vmax are most important factors you need to remember when we talk about enzyme activity. So, what is Km? Km is the Michaelis constant. It is the Michaelis constant. So, when we say Km, so if I put a formula of the Michaelis-Menten equation, I would get velocity is equal to maximum velocity into the substrate by Vmax into the S. So, this is Km into plus S. So, this is the equation of Michaelis-Menten. So, this is our Km. So, what does Km suggest us? Km will suggest us the substrate concentration when the velocity or the maximum velocity has reached to half. Okay, so substrate concentration at half maximum velocity is referred to as Km. So, if I am plotting the graph again, you would see S is here, V is here, okay, and I am telling you this is Vmax, right? This is the Vmax. So, where is half Vmax? So, I am thinking this is your half Vmax, okay. So, if I am dropping a perpendicular down, that would refer to my Km. So, what am I showing you here? Km is the substrate concentration at half maximum velocity. This is an important part you need to remember about Km. Now, Km is a constant or Km is a signature for the enzyme. Every enzyme substrate complex would have its own Km. So, when a Km is low, that means it binds to the enzyme with a very high affinity. The bond between the enzyme and the substrate is very strong when the Km is low. Vice versa, when the Km is increased, the affinity goes low. This is the relationship between the enzyme and the substrate with respect to the Km. So, low Km, high affinity, high Km, low affinity. So, after the basic of Km and Vmax, let's go back. What are we asking here? Now, what has happened to the rate of reaction? what has happened to the velocity once there's a change in the pH. So, what we are understanding here is pH is an important factor that also controls the rate of reaction. So, normally a blood pH is around 7.4. This is our normal blood pH. Now, at this pH, the action of the enzyme is maximum. So, this we call it as, so if I am telling 7.4, this is the optimum pH. So, pH at which enzymes have the best of its activity is called as the optimum pH. And what is that pH? The pH is 7.4. Now, what has happened to our case over here? So, when the pH was brought down to 4.6, the activity went off. Why? Because it's undergoing a bit of disruption in the ionic bonds. So, change in the ionic bond when you bring down the pH or you increase the pH from 7.4, that is called as the change in the pH. So, disruption of ionic bonds can alter the structure of the enzyme. Okay, so what controls it? It is our ideal pH. So, 7.4 you have brought down to 4.6, ionic bonds have broken. What happens next? Now, you increase, come back to 7.4, there is a regain of the complete enzyme activity. So, what we understand here is this is a reversible reaction. Okay. So, when it is 4.6, it was minimum, you got back to 7.4, it is reversed. So, the correct answer is when you have the word pH, it is ionic catalysis or ionic bonds have disrupted the structure of the enzyme. So, these ionic bonds, if it is here, when you change the pH, it causes a alteration over here. What are the other options we are seeing here? Denaturation of the enzyme due to peptide bond hydrolysis. At the first place, what we have to understand here is denaturation does not affect the peptide bond. Denaturation is mainly for secondary, tertiary, quaternary structure of proteins. Peptide bond comes in the primary structure. So, avoid option number A here. Alright. Now, coming to option number C, irreversible loss. I told you, it is, the sentence is telling that once it's brought back to 7.4, the enzyme activity has regained. So, definitely it is not irreversible, this is reversible. Covalent modification, no, covalent is also a very strong modification. So, that is also not possible here. So, it is not a covalent bond, it is or a covalent modification, it is the ionic bonds when you see the word pH. So, let us just reflect on the other factors, okay. Temperature also will show a graph like this, okay. pH and temperature both have a similar graph which is called as a bell-shaped curve. So, this also is the optimum temperature, this also is the optimum pH. The temperature at which the enzyme shows maximum of its activity is called as optimum temperature. So, what is a body temperature? A body temperature is 37 degrees Celsius. When the body temperature is 37 degrees Celsius, the enzymes have maximum of its activity at that particular temperature. So, temperature, remember, bell-shaped curve, optimum temperature 37 degree. pH, yes, we did it. Also, some exceptions for the 7.4 blood pH, we have the pH mainly of the digestive enzymes, especially pepsin, which is present in the stomach. So, what is the pH of the stomach? It is mostly acidic because of hydrochloric acid. So, 7.4 cannot be maintained. So, pepsin, which is a proteolytic enzyme, will need a very low pH as its optimum pH. So, these are 2 or 3 exceptions. So, digestive enzymes are exception to the rule that pH of 7.4 is ideal. The rest everything remains the same. Substrate concentration. Now, what happens with substrate concentration? The same curve, if I have to show you, yes, I will draw the same graph, this is S, and this is the velocity, okay, and you have increased the substrate concentration and you get a graph like this. I would call this graph as a hyperbola graph, a hyperbola graph. Now what are you seeing here is, when we have increased the substrate, the rate of reaction has increased. After some time over here, it has reached its maximum velocity. It has reached its maximum velocity. After which, even though you are adding a substrate, it is not going to cause any amount of change because it has already reached its equilibrium point. So, the graph, we do not get a graph, a linear graph, but we get a graph which is a hyperbola graph. So, hyperbola graph is a graph for substrate concentration. Increase in the concentration of substrate increases the rate of reaction, but after some time it reaches the maximum and it stays in that plateau phase. Now, if I would want to draw the Vmax, which is at half maximum velocity, and I drop it down, I would get my Km. So, Km here would mean half maximum velocity, that is the Km, the substrate concentration at which the enzymes have reached half maximum velocity. Okay. So, this is a graph we see with substrate concentration. Okay. So, Km would be the important factor in this particular graph. Enzyme concentration, this is a linear. What is a linear mean? If I increase the enzymes, the rate of reaction increases. So, I keep on adding the enzymes. I have to remember that substrates are in the good quantity and I keep on adding the enzymes. I get a straight line, I get a linear curve. That means addition of enzymes will increase the rate of reaction proportionately. Yes, so these are the four important factors: pH, temperature, substrate concentration and enzyme concentration. So, we have understood the the option for pH as a factor which affects the enzyme activity.
To watch the full video, download our app on App Store and Play Store.